Mr. Minnick, helping students with this practice test. Global variables are bad. Bad, 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 so that's definitely false. I'm circling the false answers, by the way. Function created with int. Yes, int is a whole number, and a function's the first line of code in a function, like this right here, the word void means that there's no return. But if there were the word int there, that means we're returning an integer with a return statement. So number 2 is definitely true. I'm not circling the truths. Number 3, no, you do not put false. You do not put a semicolon there. The header of a function is the first line of the function, like this one right here, where there is no semicolon. Don't confuse that with a function declaration statement, which I don't have an example to show you here, but function declaration statements, also called function prototypes, they do have a semicolon. Number 4, of course you should reuse functions when possible. Reusability is one of the main justifications for using functions. Number 5, yes, the very first line of a data file that's used for sequential access, perhaps the number 2 that would be there, of course, that is the first record that's read from the file. Number 6, you cannot do both input and output with a sequential access file. It's one or the other. So that's false. Number 7, that's the opposite. A global has scope around, say, the whole planet Earth, whereas a local variable is only your hometown, perhaps Reading, Pennsylvania. So that's false. We did not study this. There is no such thing, as far as I know, as a square function built into C++. We certainly didn't study it, and it wasn't in the notes or anything else related to this class. Sure, a function may have no parameters in the parentheses in its function header. That's true. A text file could be created with this program Notepad that exists on modern or at least old-fashioned Windows computers. And often text files that would look like this, a bunch of numbers down the left edge, that is exactly what a sequential access data file would look like. So that's definitely true. Consult the notes for the 5 steps of the programming process. I believe that the word that we're using in this course is define the problem. There are other words that I would take there for full credit. Define, develop an algorithm, code, write the actual code, test and debug, and then document and maintain. That's a possible set of answers there for that question. Number 2, let's trace this code. The variable num is equal to 5. That passes down to quant, the parameter. That 2 passes to PR. Follow the order of operations. That 5 plugs in here and here. The 2 plugs in here. According to the order of operations, we multiply that to 10 first. Then we take 5 minus 10 is -5. That -5 is returned as an integer back up to the spot where it's couted. And then because of the endl, whatever comes out of this ends up being below it. Now we have to erase everything and reuse that function named mystery. But in this situation, we're reusing it with the parameters 2 plugged in for quant, and num, which is still 5, that plugs in for PR. 2 times 5 is 10. 2 minus the 10 is -8. That -8 is returned, plugs in there after the endl, so that means the -8 goes down here in your output. Number 3, the variable num. Hey, this is a loop problem. I should probably trace it a little bit and keep track of my variables over here. For some reason, I'm having trouble with the mouse. So I have this variable num. It's equal to 3. The variable I is initialized to 6. We loop until the I hits 3. Anyway, mystery 2 is a function. It's typed out here. I plus 1. Now at this moment, I plus num, I meant to say, that's 9. 9 is passed as a parameter. It plugs in here for num2. It's simply being couted. The number 9 is printing out. There's an endl. So we're blinking down here. We're finished with this void function, so we just return back up to this line of code. We hit that curly brace, which loops us back up. We do the I minus minus. I is down to 5. 5 is greater than 3, that's true. So we go through the loop. Now at this moment, I plus num is 3 plus 5, which is 8. 8 plugs in here. We're couting 8. We're going back up. I goes down to 4. 4 is still greater than 3. 4 plus 3 is 7. The 7 prints out. We go back up. I goes down to 3, and that's now false. 3 is not greater than 3. That's the final. Those are the final values, and there's the output. Number 4. Number 4, with the given information, if we're declaring something, we need a data type. It would be ifstream. You're supposed to know that, not int, not double. The name of the variable in question is infile. And instead of setting something equal to 0, if it's a file that you're connecting to a file pointer, you have to name the file and put it in double quotes with a semicolon. On this question, this is also a declaration statement, so we need a data type. The appropriate data type here would be ofstream. The name of the variable, also known as a file pointer in this given question, is outfile. And it's connecting to a file named data.txt. So we need double quotes around the file name data.txt and a semicolon, of course, to end that C++ statement. A call statement that calls a function display receive. Just the name of the function, spelled correctly with a required set of parentheses, and of course a semicolon. Because it has no parameters, there are no words inside the parentheses there. Because it's void, you would not have a cout statement or anything like that ahead. It would just be kind of like display menu that you might have used in a previous programming assignment. Number 7, we're writing just the function, not the whole program that calls the function. So the function header would be the return type, to be determined later. The name of the function comes next, which is specified as dav2. It takes 2 parameters. They both need data types here. They're being specified as integers, so we use the keyword int. They're given, the names are given in the problem. You need to type the word int in front of both parameter names. There's your function header. We need the body of the function that actually does what it needs to do. It's going to return the average. I'm going to do it on one line of code. I need to add the 2 things that I'm computing the average of and divide it by 2.0 so I don't lose any decimal places due to what's called integer division. I need the 0.0 there, and that's probably that could be a decimal number. So we need double here instead of int. And I need a closing curly brace to finish out the body of the function. There are other ways to do this using local variables if you want to break it up into more lines of code, but this is perfectly fine, especially for a test where you don't have a lot of time to write out a lot of code. Number 8, I gave you the function header. You just have to write the body of the function. We could do that in one line of code. No, we can't. We could do it with an if statement. Now, if x is greater than y, and x is greater than z, then I know conclusively that x is the greatest value. You are told that the three parameters are unique. So you don't have to worry about two numbers being equal to each other. If x is greater than y and x is greater than z, then we can return x, and mission accomplished. But what if y is greater than x? So let's use an else if optional clause. And if y is greater than x and y is greater than z, then return y. Now we could do else return z, and we could do else if z greater than x and z greater than y. But if we get this far in a function and we haven't returned something else, we know that at this point conclusively that we should be returning z. Z must be the largest number. So I'm finished, and I need another closing curly brace, which for technical reasons I can't easily put over here lined up. That curly brace matches this one. So there's an answer. You should now run through this with a bunch of test cases, just pretending that x, y, and z are different numbers, perhaps like 1, 2, and 3, where the 3 should be the expected return value. If you have, say, 3, 2, and 1, plugging in for these three parameters in that order, the x should be returned again, the value 3, but this time it's coming from the variable x. And perhaps you want to put a large number in place of y. And since we weren't guaranteed that these were positive numbers, maybe you want to stick some negative numbers and even the number 0 in to see if the logic is correct. So test your code that you wrote under pressure quickly on a test. Okay, now we have to write a full program here in number 9. We don't need comments. We don't need a lot of extra stuff. So, but we do need include IOStream. Based on the way I teach this course, we should be using namespace standard. And we allow room here for a function declaration that we'll have in this problem, int main. Okay, I'm keeping it short and sweet here. The user needs to input 2 decimal numbers. I need to declare those variables. I'll just declare them as, I'm not even going to set them equal to 0 here. I'm going to use a little bit of bad style. I'm not even prompting the person with a cout because it didn't say that I have to prompt the user. So the user inputs C in, num1 rather, C in num2. And we're supposed to see out the difference. So I'm going to do it all in one line of code. I'm going to call this function that I haven't typed out yet called difference. I'm going to pass the 2 parameters, num1 and num2. It will throw an indel in just for nice style. Return 0 to finish this program. That's the end of main. I need a function called difference. If you have two decimal numbers and you subtract them, the return type is probably going to be a double. The name of the function is difference. It takes 2 parameters here. They're both doubles. Now I'm purposely not going to use num1 and num2. I'm just going to use, say, x. No, I'm going to use numb with a b, 1, and num2. And they're both doubles. And I'm going to return whatever the first parameter is minus the second parameter. This is a quick way to do it. And that function header, I'm going to copy and paste and slap it up here as the function prototype and add the necessary semicolon. I believe this is the answer there. Just to make it consistent there, let's make it all red so that you can see the answer. So one more slow pan through the answers on this video. There's number 9. There's number 8. Numbers 4 through 7. Numbers 2 and 3. And number 1 there. And the true false is where all the falses are circled. Have a great day and good luck on the test.